Our planet has this incredible, invisible engine. It's been running for billions of years, and it powers literally every single living thing. But this engine doesn't run on gasoline or electricity. Nope. It runs on something way more fundamental: the constant recycling of the building blocks of life itself. So today, we're going to pop the hood and take a look at Earth's essential cycles. Here's a concept that'll kind of bake your noodle. Think about the energy we get from the sun. It's on a one-way street. It comes in, powers things, and then poof, it's gone. It flows through the system and out. But the actual stuff we're made of, that's a completely different game. The carbon, the nitrogen, the phosphorus, it's all on an endless loop. It is, without a doubt, the greatest recycling program in the universe, and it's the only reason life can exist. And this whole mind-blowing system has a name that sounds, well, a little intimidating: the Biogeochemical Cycle. I know, it's a mouthful, but if you break it down, it's actually perfect. You've got bio for life, geo for the earth, the rocks, the water, the air, and chemical for the elements making the journey. It's just the story of how matter moves from the non-living world into the living world, and back again, and again, and again. All right, so here's our game plan. First, we'll get the big picture of this great recycling system. Then, we'll follow a single nutrient on its journey. After that, we'll get into the two main types of cycles, see how we humans are kind of throwing a wrench in the works, and then wrap it all up with why this is so important. Okay, let's start with a really crucial idea. When it comes to the raw materials for life, Earth is a closed system. Seriously, think of it like we're all on a giant spaceship, hurtling through the cosmos. We can't just stop off for more carbon or order a delivery of nitrogen. Everything we have is already on board. That means recycling isn't just a nice idea, it's non-negotiable. It's the only way life can go on. So what is this precious cargo we keep recycling? Well, you might be surprised at how short the list is. Check this out: just 5 elements. Yep, 5. Carbon, hydrogen, oxygen, nitrogen, and phosphorus make up over 95% of every living thing. From a giant redwood tree to the bacteria in your gut, we are all built from the exact same handful of elements, just arranged in different ways. It's pretty wild. Okay, so we know what's being recycled. Now let's dig into the how. And probably the best way to do that is to pick one little nutrient atom and follow it on its epic adventure through the ecosystem. So almost every one of these cycles follows the same basic 4-step pathway. First, the nutrient is just hanging out in its non-living storage tank, or reservoir. That could be the air, the ocean, the soil. Then, step 2, a producer, like a plant, comes along and absorbs it. Step 3, that nutrient moves up the food chain when an animal eats the plant. And finally, step 4, when that animal or that plant dies, the real heroes of the story, the decomposers like fungi and bacteria, break it all down and return the nutrient right back to the reservoir, ready to start the whole trip over again. So that 4-step process is the basic model. But, and this is a big but, not all cycles are built the same way. We can basically lump them into 2 main categories, and the difference between them has huge consequences for how stable our planet is. On one side, we have what ecologists call perfect cycles. These are the gaseous cycles. Their main reservoir, their main storage tank, is the atmosphere or the oceans. Think of them like a global superhighway. Nutrients move around fast, they're easily accessible, and the whole system can correct itself relatively quickly. But on the other side, you have the imperfect cycles. These are the sedimentary ones. Here, the nutrients are mostly locked up in the Earth's crust, in rocks. And as you can probably guess, getting nutrients out of solid rock is a really slow, clunky process, which makes these cycles way more fragile and easy to mess up. And this is the perfect illustration of that difference. The carbon cycle? That's your classic gaseous or perfect cycle. Its main bank is CO2 in the atmosphere, and plants pull it into the world of the living through the super fast process of photosynthesis. But the phosphorus cycle? Totally different story. It's sedimentary. Its main reservoir is solid phosphate rock, and the only way it gets out is through the painfully slow process of weathering and erosion. And when I say slow, I am not kidding. Once a phosphorus atom washes into the ocean and settles on the seafloor, it can be taken out of the game for millions of years. It's just stuck down there until maybe some massive geologic upheaval pushes those seafloor rocks back up to the surface. This is the great bottleneck of the phosphorus cycle, and it's exactly why we call it imperfect. Which brings us to the most urgent part of this whole story: our role. For most of Earth's history, These cycles chugged along in a beautiful, delicate balance. But in just the last couple of centuries, human activities have become like a giant wrench tossed into the gears of this ancient engine, and we're starting to overload the entire system. It really all kicks into high gear with this one activity, burning fossil fuels, which takes massive amounts of carbon that were safely locked away for millions of years and injects them into the atmosphere at a blistering pace. And the end result of overloading that once perfect carbon cycle is, of course, the climate change we're all grappling with today. It is a stunning example of how we can fundamentally alter the planet's operating system. And the sheer scale of our impact is, well, it's staggering. Just look at the nitrogen cycle. Thanks to industrial fertilizer production, we humans now fix more nitrogen, meaning pull it from the atmosphere and make it usable for plants, than all natural processes on Earth combined. Let that sink in. We have effectively doubled the amount of reactive nitrogen entering the global ecosystem every single year.
So what happens to all this extra nitrogen and the extra phosphorus we mine for fertilizers? Well, a lot of it washes off our farms and ends up in rivers, lakes, and oceans. This triggers something called eutrophication. Basically, it's nutrient pollution that causes these huge algae blooms. But when all that algae dies, the decomposition process sucks all the oxygen out of the water, creating vast dead zones that literally choke the life out of aquatic ecosystems.
So let's zoom back out. Why does any of this matter? Why should you care? Because these cycles aren't just a topic for a science textbook. They are quite literally Earth's life support system, and they provide all of their services to us for free. I mean, think about it. When these cycles are running smoothly, they generate and renew the fertile soil we need to grow our food. They scrub the air we breathe and purify the water we drink. They are the quiet, tireless background processes that sustain every living thing on this planet. They don't just tell the story of life, they are the story of life. So we've seen how this incredible engine works, and we've seen how we are, intentionally or not, putting it under incredible strain. We've become saboteurs of our own life support. And so the question that we're all left with is this. Now that we understand the machine, how do we finally learn to become better mechanics?